Now the problem we're about to work now deals with doing what's called a loan amortization. And this is the process of dividing the payment that we make on a loan between the interest we owe the bank and for use of their money and for principal repayment. In other words, every payment you make, part of the payment pays the bank for the use of their money, the interest. The other part now pays down how much you borrowed. And now this problem reads this way. It says set up an amortization schedule for a $25,000 loan to be repaid in equal installments at the end of each year for the next 3 years. The interest rate is 10% compounded annually. Now that we borrowed $25,000 for 3 years, 10% interest, annual payments, what that is known as now is the terms of the loan. And when you know the terms of the loan, you should be able to calculate the payments on the loan. And so in this case, here's the terms of the loan. The payments that we make on a loan, they're all the same, and they come at the end of every year. That's an ordinary, regular annuity. When we have an annuity, we use our general equation for annuities. The big dollar amount is going to be equal to some annuity times the appropriate interest factor. With a bank loan, the big dollar amount is always how much we borrowed, which in this case is $25,000. The value of the annuity turns out to be the payments on the loan. That's what we're looking for. And because the big dollar amount is always at the beginning of the annuity stream when you have a loan, we use PVIFA. N is equal to the number of payments, one payment a year for 3 years. I, in this case, the annual interest, annual payments, annual interest, 10%. Solve for the payment, the value of the annuity, we get $10,052.87. Now this is what an amortization table looks like. And so if we're putting one together for our boss or our client or for ourselves, certain information you have to keep track of. One piece of information is N, the time periods. Most of us think a loan starts when the payments start. Actually, a loan starts when you get the money from the bank. That means the loan starts at time period 0. So the first time period is always time period 0. In this case, it's a 3-year loan. We're going to make one payment a year for 3 years. So we're going to have time period 0, and then 1, 2, and 3. We also have to keep track of the payments. We have to know what the payment is and when we have to make the payment. Well, we calculate the payment to be $10,052.87. The terms of the loan say we're going to pay the bank back at the end of every year for 3 years. So we know the timing of the payments, we know how much the payments are. The interest and the principal now, that's what we're trying to do here in this process. Separate the payment between interest and principal repayment. And what you see in the brackets here, this little formula now, this is how we go about separating out the interest and the principal. And simple little formula, but this is what you do. This is how we do this. The other thing we need to keep track of now is what's called the loan balance. A bank can charge us all kinds of fees, origination fees, late fees, whatever. But the only thing they can charge us interest on is called the loan balance. In this case, the loan balance at time period 0, when we get the loan, that's simply how much we borrowed from the bank, which in this case is $25,000. So we start the loan at time period 0, owing the bank $25,000. We use that much of their money for a year before we make our first payment. They're going to charge us 10% interest per year. 10% of $25,000 is $2,500. So when we make our first payment to the loan, to the bank rather, $2,500 of that loan payment will be interest. The difference, the payment minus the interest, is the principal portion of the first payment, which in this case is $75,52.87. So with the first payment, we paid the bank $2,500 for use of their money, and we paid back $75,52.87 of the money we borrowed, which means that the loan balance after the first payment is going to be the beginning loan balance minus the principal portion of the first payment. It turns out to be $17,447.13. So we start the second year of the loan owing the bank $17,447.13. We use that much of their money for a year, they charge us 10% interest. 10% of $17,447.13 is $17,044.71. The payment minus the interest gives us the principal portion of the second payment, $83.08.16. What's going to be the loan balance at the end of the second year? Well, it's going to be $17,447.13 minus $83.08.16, which gets us a loan balance of $91.38.97. We start the last year owing the bank $91.38.97. Use that much of their money for a year before we make our last payment. They charge us 10% interest. 10% of $91.38.97, $913.90. The payment minus the interest is the principal portion of the payment, which turns out to be $91.38.97. $91.38.97 minus $91.38.97 is 0. Perfect amortization schedule. The loan balance is 0 at the end of the third year. A loan is over when the loan balance goes to 0.